Okay, looking at question 18 and 19 of the Tech Active Maths Methods External Exam from 2023. So, question 18 is a nice little combination of area under curve and area of a triangle, or not a right angle triangle. We also have a parabola that we need to solve for the equation of. So, firstly, starting with that, we want the equation of this parabola. Now, what do we know about the parabola? We know that the distance across here is 8 and the height is 12. So that means our turning point is going to be at 412 because that's halfway across and up to there. So we've got turning point at 412. So we can use our turning point form for a parabola where we have a outside of x minus h squared plus k. And so we can then put in a is x minus 4 squared plus 12. We then know two other points on the line that we can use to solve for our a value. So we have our 0, 0 here at the start, and here we have 8, 0. So I'm going to use the 0, 0, obviously, because that's the easier one. So I've got 0 is equal to a outside of 0 take 4 squared plus 12. 0 take 4 is negative 4. When we square it, we get 16. So we have 16a plus 12 is equal to 0. We will take our 12 over, and we get 16a. So then a is going to be negative 12 on 16, which is equal to negative 0.75. So our equation then is negative 0.75 outside of x minus 4 squared plus 12. So that's our equation for our parabola. And then we want to find the area under the curve between 0 and 8. So the integral between 0 and 8 of the negative 0.75 x minus 4 squared plus 12 dx. So we can do that on our calculator. So I'll put that into my equation here. So I've got negative 0.75 outside of x take away 4 squared plus 12. When I graph that, I may need to change my window. So I want to go between 0 and 8, and I want to be able to go up to 12. And there's my curve there. And then I want to do the integral, the area under curve between 0 and 8. And there we go, shades it in. And my area is 64 meters squared. I then need to work out the area of this triangle here. So now I have a non-right angle triangle. Put a little dotted line across here. And we want to be able to work out the area of that, which means we need one of the angles. So I'm going to label this A, B, C. And then I'll find this angle C there. So I've got C squared is equal to A squared plus B squared minus 2AB cos C. So my C squared is 7 squared, and then I've got 9 squared plus 8 squared minus 2 times 9 times 8 cos of C. Obviously you could use the rearranged form of that. I tend to refuse to learn that one because this one is on the formula sheet. So I've got my 49, my 9 squared plus 8 squared gives me 145, and then I've got my 2 times 9 times 8 is 144 cos C. My 49 take 145 gives me negative 96. So I'll do that divided by negative 144 gives me 2/3 cos C. So my C is going to be second cos of my answer, which is 48.18. Then I need to use my rule, area is equal to a half AB sine C. So I've got a half times 9 times 8 times sine of 48.189. Don't forget to put your calculator back into degrees because you've done a few radian questions in this paper. So we've got 0.5 times 9 times 8 times sine of 48.18. And we get 26.828 meters squared. Now that is our triangle part, so we're going to take that away from our 64. So our area of the window is going to be 64 take 26.828 Now I've got all those decimals still in my calculator, so I'm just bringing them back down. So I get 37.17 meters squared. And then right back at the start, we're told that the weight is 5.6 kilos per meter square. So I'm going to times that by 5.6, which gives me a weight of 208.16 kilograms. Obviously, depending on your rounding, is going to depend on how close you get to that answer. Then we go on to question 9, the last question of the exam. So, question 19, hardest one on the paper. So, looking at what we've got an integral here. We know that the integral of a function is this. So, obviously, we can work backwards to get the function. We're told that a, b, and c are constants, and we're then going on to find out heights, and we're looking at gradients. So first things first, let's solve for the a and b in that function. So when we integrate that, so the integral of a on b e to the bx plus c is going to be just a e to the bx, because we are when we integrate, we are dividing. So sorry, that is the we're saying that is the integral. So to get backwards, we've got to do the derivative. So that's where we bring down the b. So the a over b, we're multiplying by b, and we're leaving this the same. So this is the so that is not the integral sign there. That is what the integral is. So to get back to that, we do the derivative. Now that we've got that, we can start subbing in some values. So we know that at h0, it's 1.22, and at h40, it's 25. So we're going to sub that into here. So we've got 1.22 is going to equal a e to the bx, and where our x is 0, we're just going to get a 0 there. So that means we'll have 1.22 is equal to a. We can then bring that over here. So we've got h of x is a e to the bx, and we're putting in our a is 1.22, e to the, and now we've got the 40x there, and that's equal to 25. So first step, dividing by the 25, and so then we get, so 25 divided by 1.22, sorry, so we're dividing by 1.22, 25, we're going to leave that in our fraction, but you could change it to the decimal, just easier with the small numbers to leave like that. Now that we've got e to the 40x, to get rid of that e, we're going to do the ln of both sides. So ln of 25 on 1.22 is ln of e to the 40x. That means we can bring down the 40x. ln of e is ln of 25 on 1.22. We know that ln of e is equal to 1, so that means we have the 40x is equal to the ln of 25 on 1.22, which then means that the x on its own will be the ln of 25 on 1.22 divided by 40, which will give us a value of 0.0755 for b. So I should have put a b there all the way down rather than the 40x. Sorry, changing that to a b. So once we've got the b, we're then able to put that back into our original equation. So we now have h of x is equal to, putting that a in is 1.22, and then we've got e to the bx, and our b is 0.0755 x. Once we've got that, we're then talking about gradients here. So to get the gradient of that, we then need to do the derivative. So the derivative of that, we're going to bring down that 0.0775, so we get 0.092211 e to the 0.0755x. Then it tells us that one gradient is 0.86 and the other one is, the difference is 0.44, so we assume that that will be 0.86 plus 0.44, which is 1.3. So then we are going to use that derivative that we had, which was the 0.09211 e to 0.0755x, and we're going to say, well, we know that the gradient at 1 point is 0.86, so So we want to solve for what the x is there. And then we want to do that for the other one, which was our 1 point. What do we get? We had to add that to our 1 point, so it's just 1.3, 0.09, 211, e to 0.0755x. So then we want to solve for those and then find the difference between. So solving those, we can then obviously do our 0.86 divided by 0.09211, and we get 9.336 is e to the 0.0755x. We can do the ln of both sides. ln e to the 0.075x. Bringing down that 0.0755x ln e. The ln e becomes 1, so then we can divide that ln of 9.33, divide that by 0.0755 to get 29.57. We then do that again for the second one, and to save on time, because otherwise this video is going to be quite long, you should get the answer of 5.2873 as the difference, which you are then comparing to your statement here that it was between 7.5 and 8.5, and then you can say that that is unreasonable to do that. Quite a long last question. Obviously the solutions to that are on the QCAA website if you want to look in a bit more detail.